Hello and welcome to the System8 Advanced Matrix Scanner video presentation. The Advanced Matrix Scanner module, or AMS, offers new and unique features to ensure success in the test, maintenance and repair of electronics PCBs under power-off conditions. This module is the 6th addition to the System8 range and can be combined with any other modules. The AMS uses the principle of VI testing, also known as analog signature analysis, in order to diagnose faults on PCBs without applying power. This technique is ideal when limited information and diagrams are available and to avoid any further damage to the board under test. Signature analysis is particularly useful in comparison with reference signatures acquired live or stored on a computer. In order to acquire an analog signature, a current-limited AC voltage is injected into the device under test and the resulting current is captured by the module. The results are plotted on a voltage-current graph to display a signature. Note that it is not necessary to understand the principles of VI acquisition to use this technique for fault finding. All VI signatures are made up of 4 basic components. Resistors have a constant voltage-current ratio and therefore generate a straight line on the display. The slope of the line is proportional to the resistance value. Capacitors and inductors cause a phase shift between voltage and current, so their signatures are circular or elliptical, sometimes showing hysteresis. And finally, semiconductors. A silicon diode, for instance, will show 2 parts, a flat section for the reverse voltage region where the diode is effectively an open circuit, and a nearly vertical section for the forward bias region where the diode is conducting. The threshold voltage can also be derived from the signature. This example shows the combined signature of a component in circuit. The System8 AMS is unique because it offers not only the VI testing capabilities just discussed, but also introduces extra features to increase test coverage and speed up acquisition, basically to find more faults quicker. As such, a frequency sweep can be used to test components over a frequency range, thus creating a 3D signature on the screen. This can be used on single components but also on ICs and even complete board assemblies. Note that the AMS is available with a number of channels ranging from 32 to 2048. Test coverage can be increased thanks to Matrix VI, a multi-reference mode of acquisition for a more thorough analysis of the device under test. Even gate-activated devices can be dynamically tested with the use of the pulse outputs. All of these features can be integrated in a step-by-step troubleshooting sequence known as a test flow, containing all saved data, settings, instructions, and even media content. Using the AMS for troubleshooting allows technicians and engineers to find faults such as leaky components, often spotted by the curvature of the linear portions and a sloping of curves, incorrect components showing completely different signatures, internal damage and catastrophic failures, usually generating unstable and fluttering signatures, inconsistent devices when the signature changes unexpectedly at some frequencies, and finally, short and open circuits. The AMS provides faster tests, greater coverage, better insight, and reduced risk. Let's now take a look at the software and the module in action. The AMS is controlled by the System8 Ultimate software, central to all instruments and test sequences for troubleshooting and fault finding. The AMS offers 2 instruments, the 3D VI tester and the Matrix VI tester. For single measurements with the 3D VI tester, select probe and adjust the parameters of the AC signal. A lower frequency of 1 Hz is introduced with the AMS in order to reduce the capacitance effect of surrounding components when testing in circuit. Click on Start and probe a test point. The VI signature with respect to ground is displayed, as well as a cursor for actual measurements. For 3D VI signatures, select Sweeps from the Frequency menu and adjust the minimum and maximum frequencies using the scroll bar. In this mode, individual VI signatures can be viewed using the scroll bar at the bottom. Note the frequency plane displayed on the screen. You may also toggle between the two different views with a single click. To save this signature, click on the Store button and a comparison mask will appear. The stored and actual signatures will be compared automatically with the result displayed in the right-hand corner. Note that the comparison mask tolerances can be altered in a setup window. Alternatively, select Live Comparison to use 2 or 4 probes simultaneously and compare signatures between a good and a suspect PCB. This is an ideal setup to diagnose faults under the same conditions. To speed up testing, clip mode can be used to acquire all the signatures from the pins of a component. You may also make up your own cables to connect to large connectors for complete board testing. In all these modes, data can be stored locally without creating a test flow. Click the Save button to create a file that will act as a folder for several signatures. Then enter the name of the file, for instance, pin 12 for single measurements or IC24 in clip mode. Within the same file, other signatures can be saved. Note that this feature can also be used to save test parameters only without any comparison masks. This instrument can also be used to run dynamic tests on gate-activated devices, a family of components that includes transistors, triacs, SCRs, thyristors and IGBTs. The principle of the test is to apply the AC signal between the cathode and anode and to generate a pulse on the gate. Note that up to 4 different pulses can be generated per cycle. To observe the effect of this test, it is necessary to switch to a voltage versus time view. In normal circumstances, the component will start to conduct or activate when the pulse is applied, thus creating a notch in the sine wave. It is particularly interesting to observe the point of activation of the device by reducing the pulse voltage. A frequency sweep can also be implemented in this mode. The other instrument available with the AMS module is the Matrix VI tester. This instrument works in clip or connector mode only, as it acquires the VI signatures of each channel against all the other channels, as opposed to ground. With a 14-pin device, for instance, 14 signatures will be acquired for each pin, thus generating a total of 196 signatures for the whole device. This technique offers a more thorough approach to VI testing to detect even the most elusive faults. It is also particularly useful if you do not know or have time to find a ground reference. The instrument works in a similar way as the 3D VI tester, with adjustable parameters, comparison masks and zoom functions. The data acquired can be saved to a test flow for future use. The concept of test flow, applicable to all System 8 modules, is to generate a test sequence to centralize all repair information for a particular PCB and to automate the fault-finding process. In each step of a test flow, one or more tests can be run and the results can be compared against previously saved data. The settings of the test are also recalled to save time and avoid setup errors. Each step may contain a range of test instructions, images, documents or PDFs, videos, websites, etc. to help with the repair process. This completes the AMS video presentation. For more information, please visit the ABI website at abielectronics.co.uk.